Hello everyone, my name is Asif Rahman and this is my CIS 9467 midterm project. The data you see in front of you on the screen is from nyc.gov and is about motor vehicle collisions in Manhattan for September 2017. The reason I decided to do the project on motor vehicle collisions is because recently there was news on General Motors having received permission from the state to have their driverless cars be tested on Manhattan or sometime around 2018. And that got me thinking about the viability of driverless cars in any city, let alone Manhattan, where no one stops for anything or anyone. And I was thinking about how people, let alone driverless cars, deal with all the people running around, all the cycles weaving in and out of bicycles weaving in and out of traffic, and the general madness that goes on New York streets. So I decided to download some data from the nyc.gov website and just go through it. So the data they have is very detailed. It goes by the police precincts. They give you collision ID and keys for each collision that happened this every month. They give you the intersecting streets, the number of vehicles involved in the collision, the number of people injured, number of people killed, if there were passengers injured, passengers killed, cyclists injured, cyclists killed, and pedestrians injured and pedestrians killed. The other tab gives you the type of vehicle involved in each accident and the contributing factor for each accident. So taking all this data, I decided to create some pivot table and pivot charts to get some useful information and find out which place of Manhattan is the most dangerous and has the most accidents. So first I created this KPI dashboard. I imported all the data to Power Pivot. And from there, I added KPIs to some of the columns that I thought was useful. And I set some goals that I thought of. They're arbitrary goals, but I thought were reasonable. So for the first one, you can see here, it goes by precinct, the sum of collision vehicle counts, how many vehicles were involved in each precinct that there were in accidents, and I set the goal of less than 75. So if the number of vehicles involved in the accident in the precinct were a lot less than 75, like you see over here 3, they would be green. If they're closer to 75, you see over here, they would be yellow. And if they're above 75, they would be red. From here, you can see only one precinct is green, precinct 22. They have the least amount of vehicles that caused the accident, only 3, but most were way above my goal of 75 vehicles per month per precinct. So you can see here, precinct 1 had 327 accidents, vehicles that were involved in accidents for September. And for the other ones, you can see it's very similar too. So a number of passengers that were killed. There only one person in precinct 27 that was a passenger was killed this month, so that's very good. You can see here the sum of motorists injured, which I guess the goal was less than 10. Most places, or not very many people were injured. Sum of bicycles here, not a lot of bicycles were involved. Only a total of 127 bicycles were involved in all accidents. And the highest being precinct 18, where 19 bicycles were involved in all the accidents. I added a slicer here that you can use to filter the data easily, or all of them are connected to it. So if I want to just see what's going on in precinct 5, I can click it and all the data will filter out, so I can just see what's going on in precinct 5. Next, there's the type of vehicle pivot, which shows the type of vehicle involved in each accident in each precinct, and if you filter down, it'll give you the reason for the accident. I decided to add some data bars to it because it's helpful visually. You can see what's going on, and then you can filter out the data based on what you need. So let's say I live in precinct 1. I want to see how many accidents were involved in a bicycle, because maybe I want to ride the bike to work, and then I can expand it and then see what the reasons were. So reasons were for the accidents. It's like driver inattention, passing or lane usage improper and other things. So maybe I could avoid doing that if I'm riding my bicycle in precinct 1. The reason I decided to hide all the data here because it looks much nicer if you have the data hidden here. So if everything were open, it would be much bigger and just a mess. So instead, it's much easier just to filter which precinct you're looking for, which vehicle type, and then go from there. There's also a matrix here that if you want to just see all the data available in the worksheet, you can just go through it. You can drill down to, let's say, precinct 5, drill down to all the cross streets where the accidents happened. So in Allen Street and Canal Street, there were 1 collision, 1 person was injured. There was a cyclist that was injured, and you can garner useful data based on what you need for here. But this is a very, I guess, inefficient way of looking at it, but this does give you all the data there, and you can go through it and look for whatever you need. The street pivot here is very similar to the vehicle pivot. It is by the intersections and the cross streets and by precincts. So you have the sum of collision at intersections, sum of vehicle at intersection, and so on and so on. And I also included data bars here because it's helpful. You can by just looking at it, you can tell what's going on. Like in Avenue 2, you can see there was a very high number of collisions. In 2nd Avenue, 136. You can see here someone died. Someone died from a collision at Amsterdam Avenue. Someone in Broadway, there were 108 collisions this month. So it's very helpful. Again, you can drill down to go even further to the cross street, or you can always use filter the data using the slicers. So if you want to just look at precinct 9 and 10, you want to look at only these streets and these cross streets, and then you can see what's going on here. You can see how many there were 16 collisions, and collision in 30th Street. There were 1 collision at 32nd Street, 33rd Street, and so on and so on. This is very helpful. Just to if you're trying to find out exact data, exact locations, and you could just input it here, and you'll get what you're looking for. The chart dashboard is all charts, as the name. There's a couple of charts here comparing and contrasting a couple of different things, and I have slices on the side that you can use to filter all the data very quickly. So the chart right here, you see the precinct per collision shows you the percentage of collisions at each precinct. So you can see precinct 19 had the highest collisions at 19%, followed by precinct 10 and precinct 18. This chart shows you the injured versus killed. So how many people were injured versus how many people were killed. So you can see at precinct 19, which is the highest amount of collisions, 57 people were injured, but thankfully only 1 person was killed. The collision versus injuries is also something that's very useful. It shows you how many collisions would happen compared to how many injuries. So you can see here there's a lot of collisions but not very injuries. So from that you can assume that most of the collisions or fender benders and nothing major. And there's many more comparisons, collisions involving bicycles, cyclists involved, and where you can get very useful data to see which is the most dangerous streets, dangerous avenues in New York, and which precincts you should avoid, where you should and shouldn't bike, where you should drive and should not drive if you want to be safe in New York. So that's my project. Thank you for listening to me. Bye-bye.